Hi my friends, today we model this assembly, which is very interesting, but you see it has no springs here. At the end you'll see what about the springs and how it works. These are the components without springs. A stand, a pendulum, two pivots, two bolts, another bolt, spring guides and spring rods. Let's start. New standard millimeters IAM. Place. The stand is the first. Place grounded at origin. The position is not an actual position. This was made with Inventor 2014 when y-axis was up. We rotate the first component by clicking on this corner and applying set current view as home. Now I cannot move this, and if I select home, you see the new position. Firstly, we place the pendulum by using this circle with insert and placing it here. Place pendulum, constrain, insert. We select this circle and axis and we place it here because the pendulum is symmetrical and it doesn't matter on which side we apply it. I rotate the pendulum, then I add these two spring rods which are in contact with the pendulum. Place spring rod two pieces. Now I want to place this sphere in this conical cut, but we cannot do this very easily. So we must place here a sketch. I have this sketch. Double click here and you see the sketch with two circles, one to the left, the other to the right. They are tangent. Let me show the sketch. Double click, F7, and you see that circles are tangent to the conical insert. Good. Then we must make visible not the sketch but the center of the circle. Visibility, now visibility, both visibility, and we apply constraint between this point which is in the middle of the sphere, and this point. Apply. The other, the same combination. What are the degrees of freedom? Rotations, all the rotations, yes, in all directions. Okay, then I place this. It was modified, that component, the pendulum. Pivot, 2 pivots. Place pivot number 1, number 2. Constrain insert of this circle axis to this circle axis. Apply. It is in another position. I can constrain. This axis must be oriented to this axis. Apply. What happens? Look what happens. This part changes its position, you see, because it must have the same axis. Here, constrain, insert, here, apply. Again, we apply a constraint between this axis and this axis. Okay, good. You see what is the effect. You can rotate the pendulum and it respects the 2 rods. Good. The next are the spring guides. Double click, 1, 2. Once again, there is a sphere to be placed in a conical insert. This part has its sketch. You see the circle here. So I have to make visible the work point, center of that circle, visibility, and I constrain point to point. Point, center of the sphere, point, center of the circle. Apply. Then axis to axis. Okay. The same with the other spring guide. Double click here to see again a sketch and a point. I make visible the point only and I constrain point to point. Apply and axis to axis. Okay. Now we have to place pins. 1, 2, 3 pins. pins or bolts. Place bolt 1, 2, escape, space, bolt long. Constrain. This is spherical. I don't have an end, so I use the center point of this last bolt. The center point is in the center, and I place it on this axis. No, I place the axis to axis, apply, and point, center point of the bolt, which is somewhere inside, to the mid-plane of this stand. The stand is here, work planes, and I select not this, cancel, constrain this plane with that center point. Yes? Okay. Same for the other two. Constrain axis to axis, apply, and YZ plane in contact with the specific bolt, which is the first, this one, with its center point. See? Here. Apply. The other bolt goes inside this, apply, and again I select this plane and the center point of the second bolt. Okay. Now I collapse everything to see the browser. Good. Now I see here 3 spring guides. Let's see where is. Oh, this is the other not useful. I delete it, of course. Now, because I want to apply a dynamic simulation, and we'll add here that springs, we have to place it not in the vertical position, but at an angle, 7 degrees. So I apply angle first, solution, and 7 degrees here from what? From this, not oriented down but up. I suppose this is up. Yes, but -7. Okay. this is the placement, but I go to pendulum and I suppress this. It stays in position at 7 degrees. I don't move it at all. Of course. Good. We go to environments, dynamic simulation. We apply gravity, double click, oriented in this direction. Okay. No matter that there are some redundancies here, because it is expected by dynamic simulation module to have this. It selects the proper joints. I don't want to see this here. I click the name of this object and I try to see what happens if I run. We'll have a message, I suppose. We don't have any message. You see what happened. And the pendulum made its movement. I place 10 seconds and once again you see the first part was memorized by the software. We continue to occupy its memory with other data. Very interesting, but not what we want to see and to have. I stop here, back, and now I add the springs. The springs are assimilated as joints. We have an option for this: spring, damper, jack. And we have to select 2 points, point and point. We select the center of this circle as the first point, and you see we move from the component 1 to component 2, apply, and we see a big spring there. We have to edit this spring in order to be as we want to be, but the ends are okay. How to do this? We double click here and we open also the options. We place values. 2.5 Newton millimeter, tab, 82 is the free length. Then we go to here, the radius of the spring, 3.5. Tab, you see the modification. The number of facets to be presented when it works is maximum 10. The number of turns also 10. The wire radius 1 millimeter. Tab. Okay. Now we have a first spring placed here. I want you to look careful because I want to run the simulation, and you see what happens with the spring. The spring has a very nice behavior as we expect. The start was with 7 degrees to the right, and of course this moves from right to the right. I will change the 10 seconds to 6 seconds, but let Inventor to collect all the data. Now this is finished. Go back, disable construction mode, and we insert the other joint, spring, between this face with this point. We select a point here, and this face with another. Okay. Double click again. 2.5 Newton millimeter, 82 the length of free spring, 3.6 is the radius here, tab, 10 facets, 10 turns, 1 millimeter for the wire radius. Okay. Now we study what happens, but not 10 seconds, but 6 seconds. Again, Inventor collects data. It moves slowly and with stops, but we wait to finish, and now it is finished. Take a look now, because I go back, I don't disable this, and I run again. Now the movement is uniform and nice, because Inventor uses the collected data and not compute anything now. What can we do here? Well, we can think that here is a friction, and we can add the friction. If I place only the trace of this point, apply, and I run again, you see that from end to end is the movement forever, because no friction actions here. I'm searching for this joint by opening look, this is, there are many. If I use arrows from the keyboard, you see we have a lot of joints. This is to be modified. I double click here, and I select DOF 1. Only 1 degree of freedom is free. the rotation, yes, about the bolt. We use an imposed torque by enabling this. We apply the coefficient of 0.1 at the radius of 2, because the bolt here is 4 millimeters diameter. The radius is 2. The friction is between the bolt and the hole. Okay. I click here to hide the arrows, and I start again. Again, Inventor computes the movement. There is a small difference here, but not significant. We can change this by applying a greater friction. Double click, and I place here 0.2, for instance. Okay, start again, and you see in 6 seconds that the friction has an effect there. This was by computing, but now when I go back and I start again, all the data are in the memory, and you see the real movement. This is all for today. I go back, finish, and OK. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones include the previous ones. That's all for today. Thanks for watching. Bye bye.